Okay, so this lesson is talking about two goals, and these two goals are listed right here, and they're explaining how to, first of all, we're going to figure out how to graph real-life situations. So we're just going to draw graphs based on a real-life situation, and then we're also going to determine the domain and the range of a graph. So looking at a graph that's not necessarily just a couple of points, we need to figure out what the domain, which is all the possible x values, and the range, which is all the possible y values. So we'll do y values here. So figuring out what those are for a graph. All right, so let's start off just by a quick review of what functions are, what domain is, and what range is. So the first word is a function. A function is a relation where every domain value has exactly one range value. So a relation where every domain value has exactly one domain or range value. Exactly one is really important there because you can't have more than one for it to be a function. Okay, now what if you forgot what domain is? Well, domain again is all those possible x values of the relation. And the range is all those possible y values of the relation. So if we know what that is, we can figure out what a function is and what a function is not. Now let me take you back to yesterday, just to refresh what a function is and what a function is not. You can look at two things. You can look at, first of all, a mapping diagram, and you can see that a function, remember, it has exactly one, every domain value has exactly one range value. So for this first one is actually not a function. And because the first one, the domain, this domain value here has more than one range value that goes along with it. Based on those arrows, it's saying that it has two range values that go with it, and that means that it would not be a function. But the one on the right, each domain value, which are the x values and the y's, each domain value is different, and they all have their own range value. So that one, yes, it is. One more example down here, and a good note to remember, and I said this in my last video, but a function cannot have the same domain value more than once, because if you list that same domain value more than once, it's just the same thing. It's just saying that 1 goes with 4, and it also goes with 0, which means that the domain value 1 has more than one range value. So that is not a function. So good review, not a function. If we're looking at graphs, this is so important, this vertical line test. You can take a vertical line, and I'm going to take a vertical line. I'm going to draw a vertical line the best that I can. Actually, I will make it perfect here. Vertical line. And you grab that vertical line, you can just drag it all the way across anywhere, and if there's any spot on here that it crosses more than one point of the graph, then it's not a function. But on this one, it only ever crosses one point. So for instance, right here, it only crosses this point on the graph. If you keep going over here, it only crosses this point on the graph. So this is a function. Whereas if you go over here, just about anywhere on this graph, if you cross the blue graph, you'll find more than one intersection. So there's one and there's two. So that means that it's not a function. All right, a couple last examples to refresh. This one, I'll grab this down here. Again, anywhere on here, just about you'll be able to find more than one crossing of the circle. So there's two spots. That means it's not a function. And the one to the right, check that one out. So anywhere over here, it never crosses more than once, so it is a function. So no for this one, yes for this one. All right. So now that we're done reviewing functions, we can look at a function. We'll actually determine if it is, but this is a good review of story problems and figuring out what the best way to break it down and graph it is, because we want to be able to graph a function. So Mr. Pouts went for a run last night. He started off pretty slow, going for about 5 minutes, and we'll say that was about, I don't know, 5 miles per hour. Okay, and then you decide to speed it up and sprint for 2 minutes. So again, I'm going to underline the really important things here. Slow jog 5 miles per hour for 5 minutes. Then you just decide to speed it up and sprint for 2 minutes. And we'll say that's goes up to about 15 miles per hour. Okay, then I had another 10 minutes of a slow jog. And what I can do here is just clone this, because slow jog for me is 5 miles per hour. So another 5 miles per hour. Finish it off with, first of all, a 5 minutes of walking, and then falling over and stopping. So that walking, we could say, is maybe about 2 miles per hour. And then, of course, once I fall over and I'm done, that's 0 miles per hour. Okay, so after taking out what the important information from this one is, we need to give some labels. Let's graph it. We're going to show that the x-axis is time. So as time goes on, we're going to look at the speed, which would be the y-axis in miles per hour. All right, and then you can label it. I think the highest, we went 5, 2, 10, 5 minutes. That's going to give us 22 minutes total. So we'll label the end of this. We'll make that 25, because we won't go any higher than that. We can do 20, 15, 10, 5. It's not going to be perfect, but we're just kind of trying to get the basic graph of this situation. All right, so shifting gears, we're still staying with this miles per hour. We're still staying with this situation, but now we're going to look at the miles per hour. And if you see, the highest we got there is 15 miles per hour. So, I mean, we can make the top 15 if you want. So we'll go 5, 10, 15. All right. And then we just have to decide how this graph is going to end up looking. So, starting from the very beginning, I started my run here. 0 would be at 5 miles per hour. And I did that for about 5 minutes. So remember, 5 minutes, time is on the bottom. So 5 minutes goes 5 miles an hour all the way to 5 minutes. And then I jumped really fast to 10 miles per hour. Or did we say 15? All right, we went up to 15 right away. All right. And I started sprinting, so that was pretty quick. It says I only did that for 2 minutes, so, you know, only about 2 minutes here. And then I went back down to 5 miles an hour for a slow jog. So dropped right down to a slow jog. It's pretty easy to slow down. And I did that for 10 more minutes. So all the way up to, we'll say, about right here. So from about 7 minutes to 17 minutes, I was jogging for 5 miles per hour. And then the last 5 minutes, I went down to 2 mile an hour walk. So down to about 2 miles an hour if you want to estimate for 5 minutes. And we ended it here when I fell down. And that ending point is 22. All right. That's basically what our graph looks like. It might be a little bit more rounded if you would show it out. But the point here is that you can draw a graph based on a situation involving 2 different types of units. In this case, we're talking about time and speed, and you can compare them using this graph. Okay, so that's what the graph would look like. Now, let's say you have some graphs that are already completed, like this one. You already drew this one. This Sarah here. So this situation is already drawn out for us. We have a graph, and looking at the graph, it says Sarah's car is depreciating. So basically, her car started off all the way up here at 2001. She bought the car, and looks like it was 24,000 to start. That's what it's labeled. But year by year, it keeps going down. It keeps going down in value because Well, cars get old. They're the best when they're new. So it goes all the way down to here. All I want you to do to figure out the domain and the range is to figure out what the highest and the lowest values are for both the domain and the range. So I can take this and I can clone that. And remember, domain is all the x values. All the x values. So x values, if you want to remember x values. Okay, that's weird. We will hit undo. X values. So x values go along the x-axis. So looking at the graph along the x-axis, which is this bottom one here, looks like the highest along the x-axis, the highest number that this graph goes to is 2007. So that's 2007, and the very lowest is only 2001. Okay, that's the highest and the lowest, and that's your domain. That's just showing your domain. The domain goes from 2001 to 2007. Range, on the other hand, is in blue. It's based on the y values. And look at the y-axis. So you want to figure out the highest one is. So it looks like the highest one is up here, and we circled that. That's at 24,000. It says it's actually labeled. So the 24,000, and that's the value in dollars. And the lowest is all the way down here, and it looks like it's at 5,800, and that's the value in dollars. So your range of y values here is from 5,800 to 24,000. And that's exactly what I want you to know. And again, with this one, if you want to check if it's a function, use that vertical line test, and you can drag that around. We'll hit undo. Grab this. Anywhere on this function, it'll never cross more than one point. So yes, it is a function. Okay, I want you to try this one. All right. So what I'm going to do here is I'm going to figure out the highest and lowest of both the domain and the range. So this situation, it looks like the number of tadpoles that are in a pond, which is kind of interesting if you think about it. And for some reason, this is having issues. And I lost the mouse. So back to business here. If you're looking at this graph, remember the domain is just those x values. So it goes along this x-axis right here. All right. So the farthest it goes on the x-axis would be the highest of 1999. And the lowest it goes on here would be all the way down to 1990. So our domain goes from 1990 to 1999. All right. The range, though, the range has to do with the y-axis. And we're going to draw the y-axis in green. That goes up and down. The y-axis, we just want to know what the range. So the highest point on the y-axis is right here. I'll show that one in red just so you can tell the difference between that and the graph. And that, if you want to estimate, is about 1,500. So 1,500 tadpoles. Whereas the lowest point is right here. Right on the point right there. And that would be 200. So our range goes from 200 to 1,500, which is very, very, very nice. So you can see the range is the height, and the domain goes from side to side. And again, with this one, yes, it would be a function because it would pass the vertical line test. So now that is how you go about finding the domain and range of a graph that you already have, and make sure that when you are graphing one, you just follow the directions, you break it apart step by step, and you can kind of estimate how it's going to go when you're creating a graph. So that is how we want to achieve these two goals of determining domain and range, and also graphing real-life functions.